Good morning and welcome to Eggemoen Aviation and Technology Park. Together with me I have Rune Slandberg. Rune, why are we here today?
Today we're going to talk about drones, satellite communication, navigation, safe integration and U-space and how to tie it all together.
Well, what happens when we tie all of this together? That's maybe some of the things we hope to get a closer explanation to today, but...
That's when magic happens, isn't it?
Yeah, and one of the magicians, he is right in front of us. And this is the entrance of Robot Aviation.
Welcome to Eggemoen Aviation and Technology Park and Robot Aviation.
And this is your garage.
This is my kingdom. This is where the magic happens.
So Niklas, excited to meet you.
Good to see you.
Been looking forward to this for a long time, actually.
Yes. We look forward to show you what we're doing here today. Robot Aviation is involved in many different projects, and SATCOM is something that we're very interested to incorporate into all our aircraft. We have anything from small drones that you see here behind. We have the large FX450 that we use on interesting projects in Norway right now. And it's also a very good candidate for SATCOM.
So this may be the future of integrating SATCOM, Niklas. But Niklas, this is not what you are working on today. You have other units where you are integrating drones, satellites into.
Let me show you what we're working on here. Because this is a little bit unique. This is a very small
I think you need to speak up because of the sound in here.
I will do that. So this is a quite small drone. It's a 3 meter, we call it FX20. It's an electric drone with 4-hour endurance. And with that long endurance, it is something that is challenging for direct line of communications because we are normally limited to about 60 kilometers range. But with the SATCOM technology that we have integrated here, we will reach much further. The capability of this aircraft is actually 360 kilometer range. That's the fuel range, so to speak, although it's electric. And we will now match this capability with the SATCOM technology. And as you can see here, we have integrated the BGAN modem and we have integrated the antenna. And today here, together with our team from Norse, we are going to do the actual connection between the existing line of sight system and the SATCOM system. So the system will pick what is best suitable for the mission at the moment.
Seems like an interesting project. How long have you been working on this and why do you find this so relevant for this type of drones?
So this is a drone that we've been working on for 4 years, and we see that our customers really want to extend the range. They want to be able to fly much further. They want to fly line inspections. They want to do pipeline inspections. We have a customer in Australia right now that is asking us to come up with a concept for it, basically. And we're looking at flying 2 of these drones. Each drone do 360 kilometers. So that means that we can get over 700 kilometers within a 4-hour period inspected. And the enabler for that is SATCOM technology, that you are not limited to line of sight. Also here in Norway, where we have a lot of mountains, we have challenging areas where power lines are directed, where you need to search for people, search and rescue in challenging conditions. The SATCOM technology enables that, and it's very suitable for this type of airframe.
So what happens when you are then scaling down a SATCOM unit like this? In my mind, and I'm not a pro on SATCOM, and I think many of the viewers back home to them neither are, in my mind they look pretty much bigger than the ones you have implemented and integrated here. Explain to me how big is this one actually?
So you can see my hand, which is quite a large hand, but this is the size of a postcard. It has a weight of about 100 grams, and at the moment we're using a very standardized antenna, which is actually the largest component. But again, it's a streamlined antenna and doesn't affect the performance in any capacity. One of the really important things with this SATCOM terminal is actually cost delta. Earlier available terminals have been in the range of 50,000 euro, and this is actually less than 1/10 of that cost. So we're enabling SATCOM technology now into average small drones. And this I think is very fantastic. Our customers can afford this. The network exists, and it's just an additional feature for existing drones, which is going to be very well welcomed from our users.
So Rune, you need to help us understand a little bit more of the bigger picture on this. One thing is getting the unit to physically actually fit into a fixed wing like it is now, but what kind of complexity and challenges does one meet to put together a team working on this?
You need several components, and I think here we see the physical component, which I think electromechanically Knut has been working on integrating. But there is also a software component that makes the system talk together and communicates with, for instance, the U-Space or UTM service on the other side, which my colleague from Norse here, Thomas, has been working on. And right now they're in the final integration phase before testing it in a few weeks.
Yeah, during February we are planning to sort of conclude the tests of all of them. So the integration happens here now this week for the one, and then we plan for the rest of February to do our flights and flight tests.
So why don't you bring Thomas together with his unique piece together, and we can see how these things are combined. Niklas, just stand where you are just for a second. I just need to understand more and learn more about what kind of opportunities do you see this. You mentioned like power line inspection, etc. What other type of industries do you see as a potential for this?
The one that is very actual right now is actually the forestry. We have had very many strong hurricanes coming through Norway, and the forestry has lost a lot of trees. And to go out and map this, actually do that with a laser scanner to identify the number of trees and what needs to be taken care of in what priority, this is a perfect tool.
So Thomas, and good morning to you as well. I think for those that hasn't met you and seen you before, you need to introduce yourself as well and what you do in this project.
Yeah, so I'm Thomas Johansson. I'm a research scientist at Norse, where I work with machine learning and basically applying the machine learning techniques to drones.
And you're holding something unique in your hand. Show it to me closer to the camera and explain to me why this is essential for this project. What does it do and what is it?
So this is a very small computer, something called a Raspberry Pi, which many people might have heard of, and it's a so-called system on a chip. So in this project we are going to put this inside the drone, and it will assist us with essentially monitor the communication from the ground through satellites to the drone to figure out basically how much data we can send from the drone to the ground and vice versa. And this is essential if perhaps you're flying in an area where the communication link is a bit poor and you want to control the drone. Then you might have to stop all other data being transmitted. So something from the camera perhaps is not that important, but being able to control the drone is vital.
And control of the drone is vital. Of course, that also goes back to Niklas to the security and also the safety of using a drones who's controlled by SATCOM. How you use, people are not used to this. Is this something new that we should just consider is up and coming, or is this something which is just for a very limited number of activities? What do you think?
I think that this is something that will come in the future. May not be the only system on board. There will be a variety of 4G system, a normal terrestrial system, and also the SATCOM system. What I do see is that, like I mentioned, cost, size, availability is the key factor for it to be more common in our drones. Our drones are typically, we focus on fixed wing drones, we focus on large distances, long flights. SATCOM is an excellent addition to that.
So what kind of challenges do you meet now then, Thomas, to make this work as a system? One thing is the satellite unit itself. What kind of complexity is this?
Well, there's lots of systems that have to be integrated, of course, and we have to be able to connect this small thing to the autopilot inside the drone. And you have to do that in a safe way as well. Right? So.
But prior to the test now at Eggemoen, you have been testing this on your workshop up in Tromsø, I understand.
Yeah, so we have been testing this in a simulated environment. So essentially flying a drone in a virtual world and then communicating with the drone and controlling it to test basically that the concept works.
So what's your expectations then for the first flight?
Well, I just hope that we get the Raspberry Pi integrated, get it powered up, and then we see that data is flowing through the system that we have built.
Can you show us a little bit closer how you will integrate it into the drone itself? You might lean down a little bit and explain. It seems pretty tight down there.
So I think in theory we can fit it in this area. So there somewhere it will be placed.
And still a number of space. What are you going to do with the rest of the space down there, Niklas? It seems that we got a lot more space to carry around stuff here.
What is lacking in this image here is the actual battery. And being an electric vehicle for 4 hours, that will be filled.
Why don't you show us the battery so we can see what it looks like? Because I guess that's about filling the gap.
This is the normal battery we use in this one, but I guess we need to scale it down a bit because we are carrying more load and it's a bit less space in the bay. This one, usually fits in here. Actually now I can't get it in because it can't go deep enough.
Yeah, so you need to change the battery then. But that's for your workshop, that's possibly a small task.
Some smaller batteries we can use, so it will have a bit shorter flight time.
So what kind of range do you expect us then to see when everything is fitted here then, Niklas?
The aircraft will be capable of traveling 360 kilometers on one fuel or one battery load. So that is our goal, to maximize that. And with the SATCOM technology, we can start looking into newer battery technologies with more efficiency, with adding even more batteries, because the goal is not 4 hours. The goal is to do a full workday of data catching.
Well,
so we're looking forward to not be limited by the distance.
People that are not in Norway looking at this understand clearly that we are in Norway, which is pretty high north in Europe. Does that give us any kind of challenges that we need to address on a project like this?
It does. On a small aircraft like this, we are limited on the size of antenna. So the combination of antenna and the terminal we have today is actually not optimized for use up in these regions. In Tromsø, Thomas have been using this system with a different antenna, and the results have been good. At this location, we have verified that this antenna works, but we still need to match the capability of the antenna with the maneuverability of the aircraft. We cannot have an aircraft that banks 30 degrees if we only have coverage to 10 degrees. So this is the work that we now need to focus on also. Establish knowledge about what is the limits and implement that to our autopilot to not go beyond those limits.
Sounds good. I will not delay you too much more, and I think I'll grab a hold of Rune while you continue working on this unit. Rune, you mentioned before we started driving to Eggemoen that one thing is the hardware, the middleware, but there are other components that needs to be also part of a project like this. Explain to me a little bit more about other players in this project.
Especially the antenna is important, as Nicholas here mentioned. At high latitudes, the coverage for geostationary satellites, which are in geostationary orbits, they are quite difficult to catch. And something which is really fascinating with satellite technology is that there is European work on having digital navigation through satellite, which means that in crowded airspace, especially for manned aviation, if you have continuous knowledge of the whereabouts of each single aircraft, then you can have reduced the safety distance between aircraft and get more capacity in the airspace. And I think this is one of the keys where we can see closer integration with the drone technology if they use the same navigation and digital satellite communication to send continuously their position. They can be part of the same airspace without increasing the risk. And even in crowded airspace like continental Europe, this is a great way forward for drones.
Interesting. I think we need to have a talk with Atle, so while those that are looking on this webinar today will have a little bit of of a break, and we'll get back to talk with Atle from Radio Nord and Nicola from Avinor to hear their part of this project. Thank you for joining us today, Rune.
Thank you.
Safe to Fly, en app for alle brukere av droner. Tjenesten alltid oppdatert og enkel å bruke slik at du finner all informasjon du trenger på ett sted. Fly sikkert. Alltid.
Okay, Rune, you mentioned a few minutes ago that we're going to be talking about something essential for this project, antenna. Why is antenna and antenna design so crucial for this project?
So we saw this sort of shark fin antenna used today, and they are good for some cases, but especially here in the high north at the high latitude, looking at the satellite in the horizon, it gets very low and the signal gets very weak. So having smarter and better antenna is key to provide continuous coverage for satellite communication. And that's what you're going to show us today, Atle, how new type of, let's say, smart antennas can help us.
Okay, thank you for that. Yes, in this project we have been working to evaluate new concepts for making satellite antennas, and our background is from so-called smart antennas and beamforming antennas for ground to air vehicle applications. So where we come from is, I can just show you product. This is one of our best sellers, actually. It's a small 25 by 25, quite flat panel. It looks rather boring on the outside. It is just a big square thing, but I can promise you that inside here there is a lot of antenna elements placed around. It's called an array because it has some regular pattern, and we're using only digital signal processing to form a radio beam that can be steered towards the ground station. And the same technique can be applied for a satellite system, of course. So the idea here is that you have no moving parts. It's all digital signal processing. So it's quite advanced below the surface inside here.
So explain just for me that's very needs to have this with small spools. You might have an example of traditional antenna. So where do we move from until what you showed us right now? I don't know if you have an example close to it that you can show us what a typical antenna looks like.
You are familiar with the car, the traditional old-fashioned car antennas, like long whips and long rods and this kind of things. And those antennas are like light bulbs. They radiate and they in all directions, and they receive in all directions, which is a simple, nice concept, of course, with a minimum complexity. So this is the kind of the other end, where you have an extremely high complexity system with just a lot of antennas and a lot of electronics and digital signal processing. So this is not something you would put in an ordinary vehicle or a low-cost system. This is more like extreme sport in the other end, where you need extreme performance to go in places where otherwise it would be impossible to go. So that is our niche that we are focusing on in Radio Nord. And in this project, we have also looked into the concept where we can use this technique into the development of more, call it extreme systems for UAVs.
So how is it to work on something that you need to scale down to a system that's not necessarily can have many kilos of additional weight? How does that work? I mean, you are putting together pieces that traditionally is located on equipment that can. Well, it doesn't necessarily to be limits on weight, but now you're moving on an industry where weight is critical, isn't it?
Sure, and this is due to the developments of the electronic industry. You have so much more processing power available now than you did 10 years ago or 15 years ago. So just look at your cell phone and look at just the enormous development of how you can have 3D games and all these things. So the electronics become very dense and very also low power consumption, and this enables us to use that processing power in a more compact way, smaller form factor, lesser power consumption, and actually enables us to go at this. In this case, it was 2 kilograms of weight, but if you look 10 years ago, it would have been a massive wreck of systems only available for very large aircrafts. So that is the difference, the development of very compact electronics.
And it looks quite aerodynamic as well.
It is also an advantage that you can make aerodynamic things, and you can use let's say complexity in antenna design to make it smooth, and then you can take advantage in the processing part, having antenna elements that itself has low air or air drag, and then use signal processing to get the same effect as if you would have a parabolic dish or you would have a flat surface. This is the traditional way of doing satellite communication. You have this flat surface that is always tracking against the satellite, and that of course makes a quite decent air drag component, making those systems more traditionally more usable for large aircrafts, like everybody have seen on the when you're going with an airliner, you see on the top a big bulb containing the satellite dish.
Atle, where do you think this will take us in this project? I know we're not jumping to any conclusion because you're actually right in the middle of working on this, but based on your assumption and your theory and what you see of the results right now, where do you see actually the result is heading with this type of change of antenna design as you are now describing for us?
Well, in this project, we're looking in the crystal ball 5 to 10 years ahead in time. So we are looking what can become available, and it will make it possible to have UAV operations with what we call tactical drones, which is like 2-3 meter wingspan, or the kind of medium-sized drones, very far north, and Svalbard, those areas, and that is an area where, especially here in Norway, we're very interested in this area because it is an area of big commercial and national importance, and there's a lot of open seas and open areas. It's really nice for UAVs to do surveillance and search and rescue and all of these things in an area that is very deserted. So I think in a little bit of a time span that such techniques can make this possible to operate drones in those areas.
Exciting. Rune, we are moving also later to Avinor, who is wrapping things up for us. But to summarize some of the parts from Radio Nord now, where do you see this takes us when you see both what then Norse and Robert Aviation is doing? We talk now with the antenna. Where does the project stand now?
Yes, we're coming back to this to have continuous communication with drones, especially if they're far off or where you don't have the regular radio communication. And I think that antenna is a really important piece in this puzzle, from the signal from your flight computer all the way to the air management system. Of course, working here in the high north is challenging with satellite communications. So this is really one of the most important pieces of this puzzle to make it work continuously.
And I would like to add also that in the future, it's going to be a combination of systems. It means that if you have a ship, if you have a ground station in some vicinity, then of course you use a ground to air link because it has high capacity and it's also cost efficient. But the satellite is crucial because you need a continuous contact with a drone. So to be able to operate safely, you need to make sure that it's never out of coverage. You always know where the drone is. You can always communicate with it. And here the satellite systems is very complementary to what we're doing with, as I showed you, it's an air-to-ground link. So I think we'll see a complementary of system 5G, direct ground to air links, satellite, all this in a matrix and working together. And this is also the things Norse have been doing to see where you can combine all different, we call it carriers, which is the wireless link of some type. So it's very interesting to see all this merge together.
Interesting. I think one of the key things you mentioned here was the real-time tracking, and I know that also that's something Nicola is very interesting to talk about in this next presentation. So thank you so much, Atle, for joining us this morning. We look forward also to having you on board for our conference coming up in March. Rune, let's talk with our next guest, Nicola. Rune, we are getting closer to the final of this webinar, but we have another essential part of this team. Welcome, Nicola from Avinor. I think I'll let you introduce yourself, but also your position and why you are engaged in this exciting project.
Thank you, Anders. So my name is Nicola Tufekcic, and I work for Avinor Air Navigation Services in what's the somewhat newly established drone program. And here I have a special focus on the UTM part and the safe integration of drones into the skies, so to say. And my role in this project is to see what the technology and the new data from satellites, how we can utilize it for the traffic management of drones.
So, Rune, we talked about this before we started doing this webinar. Why is it so important to have somebody like Avinor to bring all those pieces together?
Yes, as Nicola and I said, we looked mostly at the technology so far, but I think we come to the maybe most important piece of the puzzle here. So bringing all this data from the drones in real time to like a UTM or U-space type of place, I think it's really exciting to look into the glass to see what can one make out of it. So I'm really excited now, Nicola, to hear the thoughts of Avinor on this.
Yes, and I think, Nicola, you mentioned a few key words that we just need to have a little further explanation of. You mentioned UTM and U-space, and many of possible the viewers back home have heard it before, but they don't know what it is and how to place it into this project. Maybe you can help us explain a little bit.
Yes, Anders. So UTM, as you know, is a abbreviation for unmanned traffic management. It's a ecosystem for handling drones. And in the first phase, this is just mainly smaller drones in lower airspace. And the system provides information to drone operators regarding airspace, NOTAMs, restricted areas, and so on. And the system today has some limitations. It's only used in controlled airspace in the area around the airport, for example, and can't facilitate for more complex operations such as BVLOS operations. So the next step for our system would be to, for example, provide some sort of service into uncontrolled airspace. In uncontrolled airspace, we have much higher potential for conflicts between manned and unmanned aviation, and also there's no surveillance there. So a UTM system could provide some help there.
That's interesting. So that's the possibility of the future. But how are you working to bring this data from drones, etc., together into this? Has this been done before, and how do you do it?
It hasn't been done before. You have to take it stepwise. We see that there is a higher and higher demand for operations within the same confined airspace. And so there is a need that both manned and unmanned aviation, that we ensure that they can see each other and talk to each other. Traditionally, this has been done through flight information services, air traffic controllers, or so on, but drones operate on a different platform, so these types of vehicles need to talk together. And our UTM system is a step towards that, where we can provide reliable information to drones, so that airspace conspicuity is always maintained. And this is actually a very big step forward towards automated and autonomous aviation as well. And if I can just show you on this how our present UTM system is today, and just for the visualization of maybe some of the problems.
Excellent. And maybe also you could talk a little bit about potential use cases or end users. Who's this relevant for?
Yes, I could. So as you can see here, this is the present day UTM system, which provides a visual picture of the airspace. The red parts of the map indicate areas which have maybe some restrictions to it. We can see the circle around the controlled airspace airdrome. Sorry. And the blue circle right here is, for example, a drone plan. We don't see where the drone is flying, and we can't use it to anything other than that we know that there maybe is a drone plan if the drone operator follows it. So what we want in the future is that we have tracking, for example, where we can follow drones and actually see where it is at some point in time. Then we can increase the volume in the same airspace. Just to show you another example, this is how traditional ATM is. You can see flight paths, you can see altitudes, you can see where the aircrafts are going. This is where we want to go with drones. In order to do that, we have to take step by step. We have to integrate tracking of drones. We have to integrate communication. Every airspace user needs to talk together. So as you can see, this is quite a immature system compared to a ATM system, but we want to, at some point, these are going to merge together. And as for the use cases that you were talking about, we can see that already today the energy sector is utilizing UAVs for the inspection of power lines, for example, or pipelines and key infrastructure. So we can see that there's going to come more and more of these operations within the same airspace, and everyone wants to fly safely and for their own sake, but also for others' sake. So what we see is that there's going to be an increasing amount of operations that take place in uncontrolled airspace for the especially energy sector inspections, but also surveillance. We can see that there's going to come logistics, the transport of let's say health services or something like that. And what we need to enable is that all of these aircrafts can fly safely in the same airspace volume. So that's the main part that we are looking into when we look into what satellite data can provide us into this project.
Interesting. The airspace is not so crowded, at least here in Norway, either manned or unmanned. But I think in future, when the volumes picks up on these kind of services? You mentioned the word automation of this type of services is important to make
Yes,
it.
exactly, Rune. Right now, the airspace is, I mean, here in Norway, we're quite lucky. We have a vast country with a lot of free airspace, but we see that volume is going to increase, and especially over densely populated areas, urban areas, cities, and so on, where there also is a market for these. I mean, the inspection side of this is in maybe maybe a little bit more rural areas, but we also have use cases which are a little bit more into the future, but we see that there is a increasing demand for automated services in the airspace, so that we need, when the volume goes up, we need to ensure that everyone can fly safely and communicate with each other and see each other. And this is going to go through a system, I think, and not via radio communication with ATC anymore. But this is something in the future, but we're preparing for it, so to say.
So now the drone community is sort of the little brother bullying the bigger brother on manned aviation. So how is this looked at from their point of view?
Well, that's I mean, we could talk about that for a long time, Rune, but you know as well as I do that unmanned aviation is very up and coming, and it is the future, and we have to just I don't think we need to put them against each other, just see how can we integrate both. That's at least the politically correct answer, I think.
So one thing is sure, the future of aviation is definitely unmanned. The question is on what time frame can we see this coming? Thank you, Nicola, for joining us. Rune, I think I will actually leave it to you to wrap up this webinar. And now we've been talking both with Norse Robot Aviation, we've been talking with Atlet, also Radio Nord, to talk about the antenna, but also then to see how everything is brought together. What's your summary if you were to help us with essence today?
No, I think that these developments we see here in Europe these days is quite exciting, and it opens up a vast number of new possibilities for future drone operations. Of course, having this real-time data is key, and I think that's, for instance, what Immarsat can help the Drone Society with, to make sure that these applications or services are available. Of course, we need the right cost for this type of services, and that's what we're working with, to have the hardware and the services at the right cost level.
Sounds good. And for those that have been following us this morning, I hope also to see you later in March, where we will also have another business conference and present our market service to talk about what is actually the needs from the market and what's the next step for actually getting also more business out of the opportunities that drones and satellites together can do. Thank you everybody for participating, and have a good day.